Hello. In this lecture, we are going to discuss about lexemes, tokens, and patterns. All these three are part of your lexical analysis or also known as scanning phase of the compiler. So the scanning phase of the compiler. So what we already know is that the lexical analysis phase takes as input a sequence of characters, and as output it provides a sequence of something known as tokens. So let us see what do we mean by these tokens. So first of all, the input to your lexical analysis is your source program written in a high level language. So the statements of the program will be sent as input to the lexical analyzer first, because that is the first phase of the compiler. So you may have an instruction like this, say y is equal to m into c plus say 10. Okay, so this is a regular semicolon. So this is can be in any language. Let's assume that it is in C. So what goes into the lexical analyzer is this string. So consider this to be a string. So this is the input to the lexical analyzer. And what we get is a sequence of tokens, something like this. Let's say 1. Okay, I'll just explain how I'm getting this. Then say ID 3, then plus, then 10, and finally semicolon. So the output of this is, for one instruction, one assignment statement, these are what you call tokens. So the lexical analyzer has to work in such a way that it, for every statement in your program like this, it will give you an output of this manner. So to understand this, let us look at what happens. So our statement was y is equal assigned m into c plus 10 and then semicolon. Okay, so what this will do is that what the lexical analyzer will do is that depending upon the language specifications, according to the language, we will have to specify that this is the assignment operator, this is the multiplication sign, this is plus, this is your statement separator. Similarly, we have to say that this is what? This is a number. Okay, these are what? These are, say, operators. And all these y, m, c, these are what? These are called identifiers. So the program or the language definition must give these informations to the lexical analyzer. And how does it do so? It does this by defining certain patterns. So it may say that this pattern, or this is the pattern for assignment. Or this is the pattern for plus operator. This is the sign for multiplication. So multiplication operator. Or it may be put together in a simple class called operator. So the language must give the pattern for each of these symbols. Similarly, now let's look at numbers, the pattern for numbers. So an integer number, say I'm talking of whole numbers, integer number, so it must have at least one digit, okay, at least one digit, or it can have more than one digit or more. So we have to define the pattern. So this is our pattern. That is, in order to be a number, it must have at least one digit. And if it is a floating point number, then it can have a decimal point like this. In that case, it should have some digit. It should have some digit followed by decimal point, followed by some digits, okay, one or more digits. All right. So in this manner, we have to give what is the pattern for a number. And these patterns, what we are calling as patterns, are represented by something known as regular expressions. Regular expressions. So a regular expression is used to represent the patterns. All right. So using these patterns, now if I go back here, I will be able to recognize, if I have a pattern given for number, I will be able to recognize that this is a number. So the pattern or the regular expression for numbers will give me this. Similarly, for identifiers also I can have different patterns. Like I may have a pattern. I may say that how am I going to define identifier names. So identifier names, I can say that should start with let's say with a letter followed by zero or more letters, followed by zero or more letters. Now if I declare a variable called y, this is satisfying this definition, this pattern. That is, it should be followed by it should be a letter, single letter started by a letter followed by zero or more. So I'd have zero more letters after this. Similarly, if I have a variable called sum, so it starts with a letter followed by two letters. Now if I'm going to allow numbers, I can say, I can specify it in here in my pattern. I can specify that I would like to have numbers, or I would like to have I should be able to declare variables like this, sum 1, that means I should allow digits also. Or if I want to assign say special characters here, so I want to have something like this, sum underscore 1. So the language definition must tell me that these are the rules for naming your identifiers. Okay, that's why in every language you have some rules of naming your variables. So so you can say that this is the pattern. So this is the description of the pattern. You have to represent it using your regular expression. So we'll see in details about regular expression. So what we have discovered here is that we have looked at something known as a pattern. So if I say an integer number is digit, okay, followed by one or more digits. Okay, so I want a number should be a pattern like this, digit followed by one or more digits. Okay, so something like this. So this is a pattern. Similarly, for identifiers, I may have again a different pattern. Okay, so using these patterns, the lexical analyzer, okay, given a string of your statement y is equal to m into c plus 10, okay, it should be able to find out that y, okay, to which class does it belong. So this belongs to identifier. Then assignment, okay, this belongs to operator. Then m belongs to identifier, and so on. So the lexical analyzer, this program here, should be able to do this identification. Now once it does the identification, it creates something known as a token. So what is this token? This token has this format. It has a token name followed by an optional attribute. So when I get y, say I get y, so for y, the token which will be created will be something like this. I belongs to the token identifier. Okay, so y is an identifier, and the attribute here I have put 1. Now what this means, that in the symbol table, in my symbol table, I have an entry for y and some more values out here, and its index is 1. So this is a kind of a pointer to the symbol table entry for the identifier here. So together, this thing is known as what? It's known as a token. In that case, what is y? What about y? Y here is known as a lexeme. I hope the spelling is correct. So y is a lexeme, and this thing here is an identifier. So what is it's a token. So token has the name or the class to which the lexeme belongs, and a pointer to the entry in the symbol table where this lexeme is entered. So this is a token. So if we go back here and see, like I showed here, so here you can see this is one token for y. This is the token for assignment. Now here assignment, this is an operator, so it does not have an entry in the symbol table, so it has no attribute. So it remains empty. Attribute is optional, so it remains empty. Similarly, ID2 for n. So that means my symbol table might look something like this. Y is here. Then I have m here, 2. Then I have c here, 3. So these are all the tokens.